Detonation, where we are busy putting death out of business. And I have an all-Australian episode here today. It's going to be a fantastic episode. So before we get into it, because I'm really excited to talk about this one, let's first thank our sponsors. That's Thrivous, that's geoprotectors and nootropics. That goes from $5 all the way up to $160 worth of free Thrivous and geoprotectors. You know how it works. The rules are in the description. Thanks to Thrivous for that. Also, I want to thank I Am Transhuman. That's David Kelly. Lots and lots of posts coming out on that campaign all the time. So make sure you go and check that out. Thanks to I Am Transhuman for supporting this episode of Detonation. So we're going to cross over to Sydney now. Straight over to Sydney. Great to see you, Mr. Wojciech. How are you?
I'm pretty good, mate. How are you?
Yeah, I'm good, thanks. Thanks for calling in to Detonation today. We're really excited to talk about 3D printing because, 3D printing, it's a marvel. It can go in any direction and it can take a species in any way we want it to take. We'll start off, I guess. What's your background? You're an app engineer, a 3D app engineer, but what's your background? Who are you? And we'll go from there.
All right. Well, in a nutshell, by app, I'm probably an applications engineer, as not really a computer engineer, but more of a physical application of technology engineer. But my actual background, I'm an industrial designer. I've been doing it for 20 years. I've worked for a whole number of different commercial companies, including automotive. I worked for Red Bull doing refrigeration systems, all this sort of interesting stuff. My personal interest lies in camera equipment and filmmaking, so that's how I got started off. And I guess my career's just funneled me into the use of 3D technology more and more, to a point where I ran the University of Technology in Sydney 3D and laser lab for about 6.5 years. And then I went more into the commercial space for 3D printing services, and that led for me, I started working for a mining company doing some design and printing of mining equipment and components for mining vehicles. And then I ended up in the medical space doing human implants. So I spent about 2 to 3 years doing that. And I guess one thing led to another. And currently I am the applications engineer at Konica Minolta, Australia. And I look after the 3D and CAD end of their industrial 3D printing applications. So we deal primarily with Markforged and 3D systems hardware, and I support that from a sort of design level. So I don't really do sales. I am the technical guy that customers talk to when they want to do something or invest, $1.5 million in a piece of hardware, and they want the peace of mind knowing that it's going to manufacture what they want to a level that they want. I'm the guy that works out how they do it, what software they use, and their post-production processes and everything in between. So that's sort of it in a nutshell.
Well, that's really cool. So basically, you're the Jedi of 3D printing. You've been around forever in the industry, and yeah, you're a Jedi. So it's really good to hear. That's a very interesting career. From university, technology, education to biotech to applications and software. You've covered the whole field. So I'm really honored to talk to you, sir, and thanks for bringing your expertise to the show. It's very, very cool. So I guess the first question that we have off the bat is, what exactly is 3D printing anyway? I mean, what is the definition of 3D printing? What does 3D printing do?
Well, I guess 3D printing is, from my end, I guess we call it additive manufacturing, because it can be confused a little bit with the hobby level 3D printing. So from my industry space, it's more called additive manufacturing, but it really is the process of building a three-dimensional object from a CAD file generally in layers. So you just add the extra axis. If you can imagine a 2D printer that prints on a piece of paper, you get your CAD model, and this is really the same across most 3D printing technologies at the moment. Doesn't matter whether they use resin, whether they use filament, whether they use powder. You get a three-dimensional model that you've generated in a computer, and then you send it to the hardware, the printing hardware, which then decodes that model into layers and generates code, which tells that hardware to print that model from the first layer to the top layer, like building a house. So it essentially just creates three-dimensional objects in physical reality from a computer file. That's what 3D printing is in the simplest way I can explain it.
That's very cool. And so you mentioned that you're in a different you're in a different sector to home 3D printers. But if I wanted to get into 3D printing at my home, what's the difference between what I would do at my home and what someone like you does?
Look, probably the price. I think anybody can get into 3D printing now because the hardware is so cheap. I mean, you can get a machine for less than $100 from Alibaba, or you can go to Aldi and get yourself a little $400 kit, which will get you started and teach you all the basic rudimentary skills and the the conventions of the process. But I guess my job looks at it more from a very much industrial point of view. So the parts that we make usually run on machines that are from $500,000 up. There's a few kind of cheaper machines, and by cheaper I mean our cheapest machine that does production parts is $30,000, and the next one up is about $120,000, and it works its way up. So it's generally just the price point of the hardware, and it is you do get what you pay for. Software is a key as well. A lot of our software to generate industrial parts goes into tens of thousands, if not hundreds of thousands of dollars, whereas your kind of maker level software, you can use some online free resources, but it's much more rudimentary than the kind of stuff that we use.
What's the most common components that's being printed in different industries right now? Where's the biggest adoption rate that you're seeing? Is it manufacturing with cars and car parts, or is it the biotech world, or like medical tech?
Depends on the part of the world. Like if you go to a place like Germany, they're very much ahead of the curve with, say, metal 3D printing used in automotive. So I know a lot of the manufacturers there are using end-use parts from metal for the cars. But if you go to a place like Great Britain, for instance, I know that GE are making stuff there for there was a lot of stuff being used for aerospace. Whereas if we're talking about Australia, from my personal experience, I think the biggest industrial kind of uptake has probably been in medical. And by medical, I mean everything from surgical guides to implants to dental as well, and jewelry. Jewelry is a very understated industry that's quietly been adopting printing for the last 10 years. I don't know any jeweler that carves wax anymore by hand. Everybody prints it using little DLP printers. Very cost effective as well. That's actually a good example of an industry where cheap printers, like say 10, 15 grand, are being used to make end use final industrial parts out of wax and castable resin. So I think dental crowns as well is a good one. There's obviously the medical space is something where you never run out of customers. You're always going to have new customers, and printing is ideal because you're only ever printing customized parts for that particular customer. You don't make there's no economy of scale. With printing, that's very important. Printing doesn't have an economy of scale. You don't make things as an injection mold where you make an expensive mold and then make millions of parts of the same thing. Every part can be different. So things like implants are great because they need serial numbers and they're customized to their particular user. So from my personal experience, I think as an industry in Australia, I think it's probably medicine. But we're obviously, with what's happened in the last couple of months, we're getting an incredible return to printing. Like a lot of companies that weren't so much interested in it 6 months ago have woken up and approached us because their pipelines have been disrupted and they want to get more control with in-house manufacturing and low volume manufacturing. So I think we'll see just random industrial companies that make parts, and it could be for anything. It could be, engines, it could be impellers, it could be, any product you want that includes plastic and metal. I think we're going to see a lot of uptake of that in the next year. That's going to be very interesting.
Yeah, let's just talk about that very quickly because that is a huge topic. But obviously over this COVID-19 scenario that's happened, global supply chains have had a massive shock to the system. They've taken a big shock to the system. So obviously 3D printing is something that we've been talking about here on the show, cube spawn, molecular manufacturing type ideas. So do you think that 3D printing will fill some of the void in supply chain shock? Because and in what way and what shape will that take form? And obviously, because it's kind of interesting that you've said that 3D printing is not uniform across the world, because you would think that there would be kind of an equal distribution of 3D printing across the world according to the different industries because of the different demand cycles. But obviously that's not true. Like you said, in Germany, you've got different 3D printing going on to the UK, going on to Australia, etc. That's very interesting. It's not something you would think of. But yes, in this supply shock scenario, as you mentioned, what is the impact, the psychological impact on the industry, or the monetary impact on the industry going forward with 3D printing?
Well, I think this is something that we've been trying to explain to people for a long time, and it's kind of come true. I know that having worked in the commercial space for a while, you go out and see customers, and I've been, I guess, on the pointy end of the design industry and the manufacturing industry when we were getting stuff from Australia, and then I was there when the changeover happened when people moved over to Asia, and your injection molding facilities and your tool makers in Australia slowly, retired or became just agents for China. And I always said to people I was, to customers and other people I've been talking to for many, many years, like, what if something stops your trade pipeline? And what if China, something happens that stops China being able to ship stuff for whatever reason? It could be financial, it could be a war, it could be a virus, whatever. And everyone would kind of just laugh it off. And lo and behold, it's happened. So I think just the idea of being able to control volume manufacturing, bring down the volume, bring down the amount of waste, bring down the amount of stuff you have to buy in bulk from overseas. For instance, I've worked for a number of companies where we would get very cheap injection molding tools for plastic parts on the condition that we purchased 2 million of those parts, where in reality we might have only needed about 100,000 of them, things like end caps and small plastic components. And then you have a whole bunch of that stock sitting in a warehouse that's hardly ever going to get used. So if you take an example like that, now that if you can then say, take even half of the plastic bits and make them out of printed nylon, say that nylon is structurally good enough to meet the demands of that design product, you can then cut that warehouse in half and you can replace it with a printer. And then all you can do is print your bits when you need them to the quantity that you need. So all of a sudden, half your warehouse is gone. You can rent that warehouse out to somebody else or sell it. So that changes your entire business model. Then you've also got, say you've got 3 guys on the same street who run nylon printing. 2 of them do automotive parts and 1 of them does medical parts. Now, with medical parts, you need virgin powder, right, in most cases. So the recycled powder you can't really use for your particular parts again, but you can use it for automotive parts. So why don't they then sell their powder to the automotive guys at a recycled rate, and so forth? So you can see you've got a whole new business model, whole new approach that impacts the amount of real estate you need, the amount of storage you need, the amount of money you spend on ordering, the amount of trade you're doing with overseas. The other issues you have to consider, and I think a really big one, I was in Queensland about 3 months ago doing talks about this around the state, and it was IP protection, right? Now, over the course of the last year, globally, it's been estimated, give or take, that there's been $980 billion lost with stolen IP through Asia, right? Now, that's incredible. So if you, by retaining all of your manufacturing capability in-house, or a bulk of it, you can essentially unplug your whole facility from any kind of interference from the outside world and run everything in-house. You can prototype and create the final product totally in-house without anybody seeing it or you having to send it off. Now, understand that in a lot of cases, you do need molded plastics. You do need the material properties of something that is molded. But in a lot of other cases, you don't. So just being able to bring in, like rein in the manufacturing and the prototyping pipeline into your own under your own control is just, like it'll just save so many problems later on down the line. And with having this whole COVID disruption, I think looking forward, it's something that a lot of people are going to take seriously and then see those advantages, for what they are now, rather than just kind of laughing them off, if you know what I mean.
Yeah. Well, I mean, yeah, you're right, and a lot of people did laugh the risk off, and the risk was always there, and it's still there, even after the recovery phase. So I think there will be a massive shift in how we do manufacturing in the future. But you mentioned two really good components. One, the IP stuff, the other, materials. Let's first just concentrate quickly on the IP, because that's the easiest one. But yeah, so on this IP idea. What's the biggest challenge for the industry going forward with IP? Does IP need to be rewritten? Does IP need to change? Does the copyright system, does there need to be a new copyright system for a new age in the 3D printing, or does the old model fit the job?
Look, to be honest with you, I think IP, that discussion is something that people have tried to find a solution to for years and years and years. With how do you control 3D printed intellectual property? You can't, because a file is a file. I mean, you can put a serial number on a file, but I can just as easily open up a piece of software that will let me get rid of that serial number. Now, if I want to rip off somebody's design and say reverse engineer a piece of plastic furniture and copy someone, all I got to do is change it by 5 to 10%, whatever the law is, and it's essentially a new product. And we've heard of that happening again and again. It's virtually the same, but it's changed enough to be different, and you cannot legally control that. Like, there's just no way. So I think overhauling the IP legal system isn't really, I think that's just something where we're going to be chasing that tail for many, many years, and I don't think there's a universal solution to it, because if I want to copy something in a computer and make it, I can, and nobody can stop me. So I think it's more about manufacturers looking at, okay, what are we, how important is this intellectual property for the integrity of our design, and what are we willing to invest to keep it as our own and put that manufacturing in house. So I think, you're kind of chasing shadows by trying to catch people who rip you off.
It's one of these.
You're never going to win that battle.
Yeah. That's why I said it's the easiest one, because it's one of these scenarios where the technology and the demand will outpace the laws, the innovations in the law system, just like the Napster and the internet outpaced the legal system, and all they could do was issue people with huge fines and try and scare people, which didn't work either. It's a mess, that one.
Exactly.
But it's a good mess. It's not a bad mess. Sorry, were you saying something?
No. I was just going to say you're totally correct, because as you can see, what that's done is people tried to control Napster, and I guess it's kind of a bit easier controlling piracy in the music industry, because if I go and start releasing someone else's music, sooner or later, I can get found out. It's a little bit different than making products, but I think what it's done is it's forced the entire music system. Like, you got guys like Bandcamp now, where the artists have a lot more control over their revenue. They've had to totally rejig the entire content distribution and ownership system. And like you say, it does actually work. There are people making art who are making a great living, instead of relying on big studios. And then, but yeah, like you say, it's no longer, CDs, it's a totally different model. And because they've adapted, I think it's the same sort of thing where we're in that Napster phase with IP for physical printed products that we're never going to win. And the sooner we have a look at, how that industry changed, the more we can sort of understand how we should change in order to control, where the revenue comes from.
Yeah, I totally agree. Something like Creative Commons, or some sort of innovative platform where the creators of these of these templates in the software industry are somehow reimbursed for their work. It's got to be a whole new system. It's probably going to come from the private sector. The government is probably going to be too slow and too, it probably can only play an assisting role in manufacturing this kind of new market, so to speak, where these technologists will come in, provide a service, and somehow rent out their product or something. But on the other side, I guess that's where you can maintain would be the actual machines themselves, the actual 3D printing machines and stuff. I think that will stay safe. But we are talking about the software product. That's definitely that's the really big problem. But yeah, all right, cool. Well, the other side of the story is the materials side. So 3D printing doesn't just it's not just atoms going. It's actual materials. Could you just tell us what materials are hydrochloric acid? What are some of the common materials you need for 3D printers to feed the 3D printing machines? What are some of the most common materials?
Look, I guess with your lower grade stuff, you can use a lot of very cheap, everything from little PLA and PET. You can grind up a bunch of recycled containers and feed them out into filament and print it if you want. But I guess from my end, we're talking about end-use components with a good surface finish and good structural properties. So, primarily we've got different grades of nylon. I think they're very common. There's a number of grades. There's fire retardant nylon that's used for automotive applications. There is your standard PA11, PA12 that's used a lot for medical devices. It can be sterilized, so things like surgical guides, 3D printed splints. You've got TPU rubbers. A lot of these are in powder format as well. Filament, the only filament-based system now that's pretty good, and that's the reason we took it on as a company, is Markforged, because they do deliver an incredibly good quality filament print that's strong. And the main reason for that is it has a nylon outer shell, but it has a continuous carbon fiber infill. So it does like carbon fiber, Kevlar, and fiberglass. That's got different material properties. But I guess when you go further up the ladder, you hit your metals, and titanium's always a good bet. And titanium's an interesting beast because we can print titanium now. Titanium is one of these metals that wasn't used a lot in the past because it's very difficult to machine, right? So we would make a lot of things out of aluminium or steel, and avoid titanium, which is light and strong. But now that we can print it with very intricate geometries, a lot of designs that would originally, say, be heavier and out of steel, or lighter but more, I guess, fragile out of aluminium, can now be made in a different material like titanium, which gives you, strength and lightweight options as well. So the ability to layer powdered metal into very fine detail components has really opened up the design end of the spectrum, where you can now, create parts that originally you'd have to choose different materials to do in a traditional way. So metal-wise, you've got, everything from tool steel to aluminium to Inconel. We're now printing copper as well. Copper was known to be a very difficult material to control because printing generally includes heat, and copper is very conductive. So by hitting it with a laser and hitting it with heat, you couldn't really control the geometric properties to hold it into shape. But now that problem has been overcome. So we can start creating materials like, parts like heat sinks, components that are very, can be customized to very high-end applications that are usually made from copper that would otherwise not be possible to make. So, you got a whole plethora of choice of metals, and nylons and, TPU rubbers are very common for industrial parts otherwise. Yeah.
What? Yeah, cool. And are any of these components subject to traditional supply chains? For example, in Australia, I know we're very mineral rich. It might be a different story here, but what about in other countries or Australia too? Kevlar, for example.
Yeah. Well, I guess you can. Here's an interesting point about that, and I've been talking to the CSIRO about this for many years, and I guess I've got my answer out of them, but I find it really interesting. Where I think the second biggest titanium mining country in the world after South Africa. I'm pretty sure that's the case. We used to be the first, and then they dug up a bunch of mines in South Africa that revealed a whole bunch of new veins. But we still have a lot of it. Now, what we do is we dig it out, and it's pretty cheap, and we ship this stuff off in its pure form to Germany and China and the US, and they powder it and gas it, and then they ship it back to us in powdered format for our printers at like 20 times the cost. So my question was always, we at this point, we're kind of material price is what's restricting a lot of people from getting into the printing game on an industrial level because, they can't afford the consumables. But if we started gassing the titanium locally, we could, without having to import and export it to, just to get it back into our printers, we could find that a lot of more people could pick it up if the consumable cost was down because it's local. So that's always boggled my mind. So I guess that's I'm not sure if that sort of goes along the lines of what you were asking, but that's
well, yeah, it does, and it makes sense. It makes sense with a lot of our mineral exports here in Australia. Uranium is another one. There's a lot that follow that trajectory of going out and coming back in at a higher cost. But again, we do ship out rocks, and we do sometimes get mobile phones back or iPhones or something, which is
right.
Up to a point was a good deal, but yes, this 3D printer game is changing everything, and I'll keep on the news to see if COVID-19 ushers in a new era of gassing our own titanium and powder creation because this could really be a game changer in how they think about this supply chain across the world. So this could have a big psychological effect on actors like the CSIRO and Department of Trade and all that. And also Department of Defense, because the DoD, has always sort of said this, but trade and all that always supersedes it and says no. We've got our own game going, but maybe Department of Defense will say, hey, no, we actually think as a national security issue we should produce 15% of our own powder or something like that, which would then open up the doors to more production of powder or something like that.
Yeah, Department of Defense is an interesting beast. They're very, very slow, very slow. I mean, you'll find that, we deal quite a bit with defense, and defense, you'd be, unpleasantly surprised with how many different sectors they have that are next door to each other that don't talk to each other. So, you'll find that, someone's gone out and bought a metal printer. It's sitting there for 2 years and the guys next door don't even know that the other guys have one, So, it's very interesting. And, it's funny dealing with them because a lot of them, you got the guys on the ground that need to replace parts in, say, a frigate or a ship that they need to use OEM parts that haven't been made since the 60s. So they're off, trying to chase this stuff up. And then it will take them 15 years to get a budget approved to put a piece of technology in that'll let them do it in-house. So sometimes they're quick, sometimes they're not. But you're right. I'm hoping that with enough industries after this whole, COVID debacle, with enough industries sort of putting their hand up going, guys, we really, if this happens again, we can't afford to be scrambling like this all over again. We have got such a rich country with, everything from minerals to skills. We've got everything here. And like you said, sometimes we do have to go offshore to get our iPhones because we can't possibly manufacture everything here. But there's just a lot of things I think where we're superfluously throwing away for the sake of saving a few dollars, to bring stuff here from overseas, when we really just by organizing ourselves better could be doing it here. It's like implementing robotics and automation. Everyone's afraid of automation because they're afraid it's going to take their job on the assembly line away. But what they don't realize is I think implementing automation has generated something like 4 times the jobs that it's lost, because every robot needs to be built, it needs to be programmed, it needs to be maintained, and these things don't run themselves. So it's just a big kind of fear-mongering campaign. But a lot of people can be retrained and reskilled, and I think it's more people being afraid of doing that rather than the technology being something that destroys their jobs. That's not the case at all.
Yeah, I totally agree. And we talk about automation here a lot, and I'm optimistic about automation for the most part. Yeah, and it's upgrading skills, and yeah, that's the point. A lot of people are very scared of upgrading their skills because they're comfortable with what they know, or etc. So yeah, that's really cool. So let's quickly just talk about the future of 3D printing. We kind of know where the industry is now. Where do you see the future of 3D printing going, in line with frontier technologies or space? Are we going to take 3D printing into space? Medical. Where do you bigger industrial? Are we going to see big industrial plants of 3D printing, or will we still need the old-fashioned metallurgy type plants? I mean, what do you? Obviously, there's construction. They're starting to 3D print houses in other countries, China notably. What do you see in terms of the future of 3D printing? Obviously, it's a big space, and there's a lot of opportunities here.
Yeah, look, I think, it's everything pivots on the holy dollar, and that's how it goes. And like I said, it really just depends on that part of the world. In China, they've got the old concrete printers, chugging out houses, and it's a very good idea. And they've got the, I guess, the manpower and the ability to do that there at a very cost-effective rate. In Australia, people have been talking about it for years. I'm still yet to see one that's actually running somewhere here locally. I think, it will grow where financially it is allowed to grow. So, you do have these forward-thinking people overseas. Generally in Australia, we're about 5 years behind Germany and America with this technology being used in a commercial space. So where, 5 years ago, VW and BMW were pumping out parts in metal, no one told Holden, and look where they are now. So you've got, I think, from my personal experience, I think it's definitely commercially going to be kind of chugging along nicely in medicine, because that's where that technology works really well. You've got your customization, and you've got your tiny industries that people don't notice that actually turn over massive amounts of printing, like dental, like jewelry. But I also think, that with COVID, I think a whole load of kind of industries that previously didn't give it a chance, like your people making just industrial components, and you can't bundle them into one area. Like I said, it could be anyone making hydraulic parts to engine parts to impellers to musical instruments. It could be whatever. I think a lot of them are going to be forced to give it a go. I think definitely from a technology point of view, space isn't really a big one. I mean, CSIRO, I've been working one-on-one with CSIRO. I was involved with the ASCAP telescope project. I've got a lot of friends at CSIRO, and they're very, very, their printing capability and use is very, very, very limited. It's not very big. They do it on an R&D level. I mean, you got on Lab 22 in Melbourne, which is wonderful. They've got a lot of nice kit over there, but it's all very much R&D. It's, it's not like 40 machines in a room. It's like something like 5, and they're all very good, but the guys, they just play with those machines. They don't have like an ongoing factory. I think bioprinting, like we spoke about earlier, bioprinting is definitely one that's growing. But once again, the ability to print, say, human bone, or to print a human kidney or a piece of human skin, it does exist, but it does still exist very much on an R&D level. It is not commercial in the way that we would like it to be. So I reckon give it 10 years and it will get there. But then you also have to consider, everyone's excited about bioprinting, but take a step back and look what it takes to legalize something through the TGA or the FDA that you can put on a human body. We're jumping through hoops to make a few plastic bits for COVID applications on a tight timeline. Like, imagine what you'll have to do to test and approve codes that will let you graft on 3D printed human skin. That could be 20 years before they pull their fingers out and actually get to a point where they can approve it. So, Australia's very, very behind with that. I think, it's nice to think of, kind of space age applications being the future, which they are. But I think what drives the direction is more who spends the most money on printing. If the most money is being spent on filament printing for, plastic bits for whatever, then that's the direction it'll go. And we'll just have to see what happens in the next couple of years.
Well, just quickly before you go, this organ printing idea. It is a good idea. Do you think it could be accelerated by an international NGO or the United Nations, like Amnesty International or something like that, who is concerned with, organ harvesting, illegal organ harvesting worldwide, or the fact that thousands of people die waiting for, organ transplants or transplants of some sort? Do you think an NGO might win some sort of lobbying agreement and accelerate that process? Or again, do you think that there's regulatory backlog that's going to suspend the advance of it?
Yeah, I think there's a backlog. I think it doesn't hurt. It doesn't hurt for people to put their hands up, and if a few politicians, put their hands up, and a few, kind of notable people get in there and say, "Hey, wake up," then someone will pay attention. But I can tell you, I was actually trying to call the TGA by phone, probably about 3 weeks ago. And I spent 2 days on hold, and I did it on my separate phone. And I was on hold for 9 hours on each day, and I did not actually end up getting through. And so I gave up. But that's what I mean. And that was obviously because of the COVID problem. But you can then imagine, they're very understaffed, they're very overworked, and they have a lot to get through. And I was doing 3D printed medical components back in 2013. And in that last 7 years, not much has really changed in respect to legislation. They kind of wake up here and there, but it does take, a bit more of a drastic move to get them going. So, it can't hurt if people lobby, but the commercial and physical, practical reality of it happening, I think, in Australia, we're very much in second gear as compared to the rest of the world. But then again, in their defense, because they're so meticulous and because they take so long, we have a much better system than someone like the FDA does, where the FDA suffers from a lot of issues like the Da Vinci robot. I'm not sure if you're aware of all the problems involved with the old Da Vinci robot. And if you want to, want some fun bedtime reading, look up Johnson & Johnson lawsuits for 3D printed hips. If people's people getting gangrene from titanium shards going into their bloodstream because no one bothered checking the quality and load testing the things over time. So all those things, you can't rush them. And certain things you can kind of accelerate, I guess. But I think with things like organs, where we don't know how a 3D printed organ will take over a period of 10 years. We don't. It's the same as not knowing. I'm sure you're aware of magnetic memory, like tapes and CDs. We don't actually know how long they last before they degrade. So there was a whole push recently of transferring all the old VHS footage from movies onto more permanent media, because we don't know how long that media will physically last, because we haven't been alive long enough to test it. And the actual technology hasn't been around. So the moment we can test a 3D printed organ in a person for 50 years and know for a fact that it doesn't explode or degrade and kill them, then I'm pretty sure they'll sign that bill. But before then, there was going to be a lot of pushback, because it's like, mate, well, we're going to put this in your body. Titanium, we know, okay, it's titanium, it'll hold. 90% of people aren't allergic to it. The 10% that are, they use cobalt chrome, and it's metal and it'll do the job. So we're good. But with a biological substance, we don't know how it degrades over time, and we don't know how the body responds to it. And I think that's going to be their pushback when it comes to taking their time to legislating it.
Wow, yeah, that's quite scary. This Johnson, I want to look that up. The Johnson & Johnson lawsuit. Well, is there anything else you wanted to say? I don't want to keep you around for. I know you're really busy. Anything else you wanted to mention about 3D printing or the future or the past or the present or whatever you wanted to say?
Look, I got a lot to say, but I think I think it's one of these wonderful technologies where I guess all that I can really say about it is that it can be made very beneficial. It can save money. It can save lives. It can be, a lot of fun to use, and it can make things a lot quicker and cheaper and easier. It doesn't have to be, expensive and difficult and scary and unreliable. It does do the job. It's been doing the job for a while in the right applications. A lot of them are not commonly known. And I just think that as a designer or an engineer, or anybody involved in our production pipeline, especially in the current climate in Australia, this is something that you should very heavily think about. and give it a go, and really, because it's something that could change your whole business pipeline and save a lot of money, a lot of real estate space without you actually knowing it. So I think it's technology worth definitely now, as opposed to 5 years ago, with the advancement in materials and quality. It's a technology that should definitely be explored by a lot more people that might be afraid of it.
In the short run, I would really like to see an explosion of spare parts and car parts in Australia. Just in the short run, manufacturing, because this COVID thing disrupted a lot of the car industry, and I think that's something simple, and it's something that a lot of businesses could adopt. I mean, I know that the initial capital investment of getting one of these machines is reasonable. The cost is always coming down, but there's a return embedded in there, because it's a once-off cost, and then after you make a lot of these standard sort of components, the cost will come down for your business, and you'll be safe and secure, and you won't have to wait for China to get manufacturing again. I think that's somewhere in the short run we could see a lot of innovation, and the jewelry as well. I like that. I like that the jewelry business is embracing a lot of this as well. It's very interesting.
Yeah, it's all there. But yeah, absolutely. There you go. That's kind of my 2 cents. But I can go on about this for the whole day. So
All right. Well, no. Thank you very much. I know you're really busy, so I really appreciate Mr. Wojciech. Thank you very much. That's not it, is it? I messed it up.
That's all right. I've heard it all before.
All right. Well, I really want to thank you for coming on. I appreciate it. That's a really good summary of 3D printing, and especially here in Australia. I'm a 3D printing optimist. Just in general, for the sake of the technology. There's, like any disruptive technology, it's obviously got its hurdles, but we do live in an interconnected world with the internet at the back, and so there's a lot of innovation that could go on, and a lot could happen. Who knows what ideas will pop up where, based off this? It's an incredible idea. So I'm excited for it, and I'm excited to see where it goes. And I want to thank you for your time.
Thank you. It was a blast.
All right. Well, that's Detonation, where we're busy putting out of business. And, I want to thank everyone who supports the show. That's Mr. Wojciech, and I'm Steel Archer, and that's Detonation.
Thanks, Steel.
Thank you.